Hello, this is Pspice from EEToolz. Today we are going to look at Ohm's law. We'll first define Ohm's law and then verify it using Pspice simulation. Ohm's law states that the current that flows through a resistor is proportional to the voltage or potential difference across its two terminals. Let's look at this resistor as an example. When a certain amount of voltage is applied to the resistor, the current that flows through the resistor is proportional to the potential difference between the two terminals. The proportionality constant is known as resistance. These statements can be summarized with an equation as follows. This equation shows that voltage is directly proportional to the current, the resistance being a proportionality constant. This can also be rearranged to calculate resistance and current. Now let us proceed to the second part where we verify Ohm's law using Pspice simulation. We will first create a new project and I will name the project as Ohm's law. Next, we will draw the circuit diagram. The circuit diagram consists of a resistor and a voltage source. In addition to other circuit elements, a circuit diagram in a Pspice should always have a ground reference. Now that we have completed the circuit diagram, let us create a simulation profile. I will name the simulation profile as Ohm's law. I will leave all these values in here to their default. Let us now assign values to the circuit elements. I have assigned a random value of 10 volt to the voltage supply and a random resistance value of 2 ohm to the resistor. Now let us run the simulation. And the results are as we expected. When we apply 10 volt into a resistor of resistance 2 ohm, the current that flows through the resistor is given by 10 divided by 2 ohm, which is 5 ampere. Let us now double the voltage applied for the same amount of resistance. And run a simulation. We observe that the current that flows through the resistor doubles from 5 ampere to 10 ampere. And now if we increase the voltage tenfold, and run the simulation, the current flowing through the resistor also increases tenfold. This is what Ohm's law states as the voltage across a resistor and the current flowing through it are proportional. We will now perform a very similar simulation to observe the same kind of effect. I will create a new Pspice simulation profile. And this time we are going to perform a DC sweep. The name of our voltage supply is V1 and we'll start our simulation from 0 volt and goes up to 10 volt with an increment of 1 volt. Now the voltage applied by this power supply ranges from 0 volt to 10 volt. We are going to measure the amount of current that flows through the resistor when the voltage increases from 0 to 10 volt. So we will use a current probe or a current marker. This current probe or current marker measures the current that flows through the resistor. When we run the simulation, we obtain the following graph. This graph shows that when the voltage applied to the resistor increases from 0 volt to 10 volt, the current increases from 0 ampere into 5 ampere. The slope of this graph, which is a constant value, is resistance. This is all for today. Thank you for watching.